Okay, AP Calculus, AB, Unit 5, Day 9, Office Hours. Here are the solutions up at the top, just to mark them wrong right. Most multiple choice, few non-multiple choice. Should have also checked these online. I think 14 may have been wrong online. It should be B. So pause the video if you need to check those if you hadn't already. And then I'm going to go ahead and go over these. So let's do it. Okay, just a regular old derivative. It's going to be 2 minus negative 2x and negative 3. So it's going to be 2 plus 2x and negative 3. Usually we would write this like that, but I see the version of the negative exponents, so that's fine. Okay. Number 2, I think we need to do the quotient rule. And if you look at all the answers, they all kind of look like quotient rule. So it's going to be, there's a negative here, so it depends on how you want to deal with that. We could assign it to the top or the bottom, one or the other, not both. Derivative low d high, derivative cosine is a negative sign, but that extra negative makes it positive. Low d high minus high d low all over low squared. So I attach the negative to that cosine. So we get x sine x plus cosine x over x squared. X sine x cosine x. So that's answer B. Okay. Number 3, find this derivative. It's going to be 5x cubed plus x to the 4th. Don't forget the chain rule. You need parentheses, 3x squared plus 1. Do you see an answer like that? Now, not quite, but maybe if we bring this up front and distribute that 5 into it, we get another version of the answer that looks like it matches answer C. So sometimes it's a little tricky. Number 4, look for the derivative of this. So this little chain rule. Derivative sine is cosine, leave the inside the same. Don't forget to do the chain rule, 2x. So it's going to be 2x cosine of x squared, 2x cosine of x squared. There we go. All right, number 5, derivative of that. So that's a y prime. Derivative tangent is secant squared. Leave the inside the same. Chain rule says you derive the inside afterwards. So it's going to be 2x secant squared x squared. 2x secant squared x squared. Okay. Number 6, we're trying to do this derivative. You want to think of it as a 1/2 power. So it's going to be 1/2 x squared minus 2x, the negative 1/2. And don't forget the chain rule. You need parentheses because there's multiple terms, 2x minus 2. Now, based off these answers, that one's for sure out. I don't know what this one looks like. I mean, do we see it there? Oh, okay. We could bring this 2 into there. And we get that. So that looks good. That looks like C. So sometimes you gotta do a little short. Okay, number 7, derivative of this. Now this I would rewrite like that. So, because the outer rule is the power rule, inside stays the same. Then multiply by the derivative of what's inside, which is negative sign. And probably might write it like this, usually, something like that. There we go. Okay, second derivative. I wonder if the first derivative is on there. That would be a good trick. So you got to find the first derivative. Outer rule first. Chain rule. derivative of what's inside. I would probably leave it with a negative exponent, especially if you look at the answers, they all have negative exponents. So the 2's cancel, I put the x in front. So we're halfway there. And that answer is on there, which is a little mean. Second derivative, so we would probably do the product rule here. X times derivative of that's going to be -1/2 x squared plus 1 to the -3/2 times derivative of what's inside is 2x plus x squared plus 1 to the -1/2 times derivative of x is 1. So it's product rule. Let's try and clean it up. So it's going to be negative x squared plus 1 to the -3/2 plus x squared plus 1 to the -1/2. Now, do we see an answer that looks like it? Gotta get a little creative here. Could we factor something out of one of these so that one of them gives it? Can we make this a -1/2 exponent or make that -3/2 exponent? Now, for factoring stuff out, I think you're going to only make the exponent go down. So I might think, well, could I make this x squared plus 1 to the -3/2? And that would be by factoring out an x. Is that right? Well, okay, hold on a second. Let's rewrite these as fractions. This might make it easier because then we can do least common denominators. Yeah. You would multiply this by x and x, right? So then you would get -x squared plus x over x squared plus 1 to the 3/2. Still just don't see that answer here. What's my mistake? Oh, wait. X squared plus 1. So then those guys cancel and you just get 1, which is also x squared plus 1 to the -3/2. Well, that cleans up nice. X squared plus 1 to the -3/2. Answer A. Ugh, that was annoying. Okay, number 9. Let's see. Let's do derivative. Product rule. Y prime equals 3x times 3x minus 2 squared. Derivative of what's inside is a 1. So, okay. Plus x minus 2 cubed times derivative of 3x is 3. So I get 9x, x minus 2 squared plus 3x minus 2 cubed. I'm trying to make this answer look like those. So I think I could get an x minus 2 out of that so that they're both x minus 2 squared. So this would be 3x minus 6, and then I'd have an x minus 2 squared left over. And then I could combine these guys together, 9x plus 3x minus 6 times x squared. X minus 2 squared, and then that would be 12x minus 6, x minus 2 squared. Does that look like anything? Looks like answer is C. Man, it makes work for these answers. All right, number 10. Trying to find the derivative of pi over 2. So y prime equals cosine 2x times derivative of what's inside, chain rule, minus 1. So y prime at pi over 2 is going to be 2 cosine pi, which is -1. So it's -2 minus 1, which is -3. There we go. Number 11. Trying to find the derivative of pi, so let's find y prime. So this is going to be, maybe we should rewrite this like that. Yeah. So it's going to be 6 tangent x over 3. So the first power times derivative of what's inside would be secant squared. And one last chain rule, derivative of x over 3 is 1/3. Okay, then we're going to plug pi into it. So we're going to get 6 times, now tangent is sine over cosine, which I feel like is easier for me to remember, times secant is 1 over cosine squared times 1/3. Now the 3 and the 6 reduce to 2. Now, sine of pi over 3, 0, pi over 6, pi over 4, pi over 3. So that's going to be 0, 1/2 or 2 to root 3 over 2. Cosine's going to be 1/2. Cosine's going to be 1/2 squared. So we're going to get those twos cancel, root 3. This is going to be 1/8 on the bottom multiplied by the reciprocal. So we should get 8 root 3. Gotta know your trig. Basic trig. Number 12, we should be like, oh, that looks like the definition of the derivative. What's the function tangent of x? What's the derivative of that? Secant squared. What's the value at pi over 4? That's what these pi over 4s are. They're where the x is. So that would be 1 over cosine of pi over 4 squared, which would be root 2 over 2 squared, which would be 1 over 2 over 4, which would be 1/2 multiplied by the reciprocal. The answer is 2. There you go. Definition of derivative. 13. Find the second derivative. So the first derivative is product rule. X times derivative of cosine is negative sine plus cosine x times derivative of x is 1. So, we could clean that up if you want. That's the first derivative. Okay, the second derivative, let's do another product rule here. So it's going to be negative x times derivative sine is cosine plus sine x times derivative of negative x is negative 1 plus derivative of cosine is negative sine x. So I think we get negative x cosine x minus 2 sine x. Now, I don't know if the answer is going to be there exactly like that, but there it is, D. Okay, 14. Says it's differentiable for all numbers except for 2, greater than 2. It's differentiable, requires continuity, so we should check continuity first by, the lazy way to do is just plug 2 into both of these, and it works. So it's continuous. That has to be true before you do differentiable. Now, differentiable, you want to find the piecewise derivative first, which is going to be 0, and that's going to be 2x. So then if you plug 2 into here, we realize that the slopes are not the same. So it is definitely not differentiable everywhere. Now, this is a horizontal line, which is differentiable. This is a parabola, which is differentiable. So it's differentiable everywhere except for 2. So one way to describe everywhere except for 2 is to say x can't be 2. So there you go. 15, find the slope of the tangent line. So you got to take a derivative. So derivative, we do low d high. Now there's a different way. We could say x squared plus 1 to the negative 1. That might be a little easier. So if you do it that way, it's going to be negative 1 x squared plus 1 to the negative 2 times derivative of what's inside. That's a lot easier in quotient rule. So it'd be negative 2x over x squared plus 1 squared. A little easier in quotient rule. You can do quotient rule, you should get the same answer. So we plug negative 1 in, you get negative 2 times negative 1, negative 1 squared, positive 2 over 2 squared is 4 is 1/2. Or you could have done quotient rule. It would be low d high minus high d low all over low squared. And we get the same derivative, right? Either way, so plug 1 into that, or plug -1 into that, and you should also get 1/2. All right, 16, slope of the tangent line. So I think we'll probably do quotient rule this time. Low d high minus high d low all over low squared. We're going to plug pi over 2 in. All right, now sine pi over 2 is 1, cosine pi over 2 is 0, so that whole drops out, and we get -1 over pi squared over 4, which if we multiply by the reciprocal, we get -4 over pi squared. Looks good. All right. 17, write the equation of the tangent line. Okay, well, we need a point, which we don't have yet. Okay, so now we have a point. We need slope, so we got to find the derivative. Now this would be a good one to do x squared plus 2 to the -1, or you could do quotient rule either way. You want to do quotient rule? Do quotient rule. Low d high minus high d low all over low squared. So we get -2x over x squared plus 2 squared. So then we need to plug 0 into this, and it's not very exciting. We get 0 over 4, which is 0 for your slope. So we're going to do y minus 1/2 equals 0 times x minus 0. And the equation ends up becoming x equals 1/2. It's a horizontal line. The equation of the tangent line is a horizontal line. There you go. $18. Find the slope of the tangent. Well, got to find the derivative. So y prime equals 1/2 x plus 2, the -1/2. Derivative of what's inside is just 1, not 0. So it's going to be 1 over 2 square root of x plus 2. So we're going to plug -1 into that. And we're going to get positive 1/2. Looks good. All right, 19. The y-intercept of the tangent line. Well, it looks like we got to find the equation of the tangent line. So we got to plug pi into the function. And sine of pi is 0, so that goes to 0. So the point is pi 0. We need slope. The little product rule here, x times derivative of sine is cosine plus sine x times derivative of x is 1. So then we're going to plug pi into that. And sine of pi is 0. This is going to be -1, so it's going to be negative pi. That's your slope. So we're going to do y minus 0 equals negative pi times x minus pi. And so the equation of the line is negative pi x plus pi squared. And they said, what's the y-intercept? Well, this is slope-intercept form, which is handy for finding the y-intercept, and it is pi squared. Okay. 20, not multiple choice. Find the equation of tangent lines at the zeros and find their point of intersection, the tangent line intersection. So we got to find these equations of these tangent lines. We got to find the zeros first. That's not the horizontal tangents. That's just when the function equals 0. X-intercepts. So we're going to set equals 0. Factoring works here. And so those are our zeros. So we want the equations of tangent lines. So we need now we know both of these go with y value of 0, right? So we don't need to plug those back in. We need the slope. So we need the derivative to be 2x minus 2. So at 3, it's going to be 6 minus 2 is 4. So the equation is going to be y minus 0 equals 4 times x minus 3. It's going to be y equals 4x minus 12. So that's one of the tangent lines. The other one is going to be, we're going to plug -1 in. And we get -4. So that one's going to be y minus 0 equals -4x minus x plus 1. Y equals -4x minus 4. So that's the other tangent line. Now we want to find their point of intersection. So that's a system of equations. I'd use substitution. You plug this into the other. We get a -4x minus 4 equals 4x minus 12. So we get 8x, if we brought these over here, equals 8. So x equals 1. Plug that back into either of the y equations. Gives you -8. So the point of intersection is 1, -8. That was a fun one. 21, average rate of change. Now we've talked about this. Average rate of change. Last chapter we did like average speed, average velocity. So this is the average derivative. So we're looking for f prime average. Now what we said is that that's just the slope of the secant line in the original graph. All right, so you have this graph, f of x. You want the average of all the derivatives between 1 and 3. So it's going to be all these different slopes. We just connect the endpoints to the secant line. The slope of that is your average slope. So we're going to do f of 3 minus f of 1 over 3 minus 1. So this is the setup. If you plug 3 in, you get 12 minus 9 is 3. Plug 1 in, you get positive 3. So we get 0 over 2, which is 0. So the average slope is 0. It's flat. That was just a rough example of the idea. Okay, 22. We're going to find the derivative at x equals 0. So I guess we just start by finding the derivative. It's going to be x times derivative of y is dy dx plus y times derivative of x is 1 plus derivative of x is 1 minus dy dx equals 0. Now usually what I like to do is plug numbers in now instead of trying to solve for dy dx. The only problem is I only have x value, so how do you find the y value? What's the y value equal? Well, if you have x, could you find y? Plug in the original equation. So it's going to be 0 times y plus 0 minus y equals 2. Y equals -2. So I'm going to go and plug both of these in right now. 0 in for x, -2 in for y. That goes away. So dy dx, if I move to the other side, it's going to be -2 plus 1 is -1. Answer B. Okay. 23, equation of the tangent lines of the graph at point. So you have the xy pair. You got to find the equation of the tangent line. So we need the slope, which we're going to do implicitly. X times derivative of cosine is negative sine y, and then a dy dx plus cosine y times derivative of x is 1. So that's just that first product rule, plus dy dx equals 2x. So that's the derivative. I'm going to plug these x, y numbers in here now. So x is 1, sine y is 0, cosine of y, which is 0. Now cosine of 1, cosine of 0 is 1, sine of 0 is 0, so that whole term drops out. So we get dy dx equals 2 minus 1 is 1. So now we have our point and our slope. So we got our earth equation line, y minus 0 equals 1 times x minus 1. That would be perfectly fine on any question except for multiple choice. Looks like we should maybe change these to slope intercept form, which was pretty easy, and the answer is there, C. 24, find the slope of the tangent line to this graph. So we're going to do implicit differentiation. 2x times derivative of y squared is going to be 2y to the first, dy dx, plus y squared times derivative of 2x is 2. So that's that first product rule plus another product rule. X times derivative of y is dy dx, plus y times derivative of x is 1, equals another dy dx on the right side. It says when y equals 1. Okay, well, what does x equal? Well, we just did this. If you plug y equals 1 in, you should be able to find the x value, right? So what do we get? 3x's equals 1, x equals 1/3. It's a little gross, but I guess we got to do it. So 2 times 1/3, 2 times 1, dy dx, plus 1 squared times 2 plus 1/3 dy dx plus 1 equals dy dx. So it's a little ugly. I still think it's better. So this is going to be what? 4/3 dy dx plus 2 plus 1/3 dy dx plus 1 equals dy dx. Let's get all the dy dx's on the same side. So we have 5/3. If we subtract them, we're going to have 3 equals. If we do 1 minus 5/3, it's going to be -2/3. And then we multiply both sides by -3/2 to get rid of the -2/3 for the dy dx. And dy dx equals -9/2. There it is. -9/2. That was a bit of work. Okay, 25, write the equation tangent line at this xy pair. So we just need the derivative. So I think we do that. I would just do it implicitly. Why not? I mean, you could do this one explicitly, not too bad, but it's quicker. Right? Derivative of x is 1, derivative of y squared is 2y the first, dy dx. Derivative plus 4 is 0. This is what you want. You have the y value. So slope is 1/2. So we're going to write the equation line y minus 1 equals 1/2 times x minus 5. And that would usually be totally fine, except it's multiple choice. They look standard-ish form. I think we want to get rid of the parentheses. I think we want to get rid of the fractions. I think we want to get the 2y by itself, maybe. Add 2 to both sides. At the mercy of their answers. Okay. Last page. Okay. 26, find the derivative, probably implicitly. Look at the answers, most of them are x's and y's. So if you were to do it explicit, you'd probably get an answer that just doesn't match any of these. Plus would be a lot more work. 2x plus 2y dy dx equals -2x times dy dx plus y times derivative of negative 2x is negative 2. So you get a little product rule there. This is what you want. You want dy dx. So I think we're going to try and get it together by itself. So I'm going to do 2x minus y plus 2y equals dy dx negative 2x minus 2y. So dy dx equals 2x plus 2y over negative 2x minus 2y. Oh, this is interesting. We take a negative 1 out of that, and look what happens. The answer is negative 1. Wow. No, I didn't expect that. All right. 2731 is a little motion review, which was last chapter, but why not? Talking about velocity acceleration. So velocity is a derivative position. So it's 2t minus 1. It says velocity of the particle after 2 seconds is what? Well, plug 2 into that, and you get 3 feet per second. All right. Acceleration is, well, acceleration is the derivative of velocity, which is going to be 2 no matter what. So A2 is 2 feet per second squared would be the correct units. What's the position at 2? Well, they gave you the position function, so you just got to plug 2 into it. It is 2. Feet would be the correct kind of units if it was in feet. T value is when the particle changes direction. Well, that's going to happen when the derivative equals 0, which is the velocity equals 0. So we take the velocity equation, which is 2t minus 1, and solve for t. And I think that should be the only place. 1/2. And it changes direction for sure because it doesn't bounce off the graph. If it was a multiple root, even number of times, and it'd bounce off the graph, it wouldn't change sign. So velocity is going to go. And we do a little quick line check if you want to see what's happening. We test t equals 1 into your velocity equation, which is positive, negative. So it's going down and then up, or left and then right. But it definitely changed direction at 1/2. 31, the particle moves to the right when? Well, moving to the right means that velocity is positive. So we take the velocity equation, 2t minus 1, and we set it greater than 0, and we solve it. Now, I don't think we need a line check this time because it's a linear inequality. So t is greater than 1/2. All right, this wasn't too bad. 32, not multiple choice, more like free response. So let's try this out. This is a good amount of work problem. It says find the derivative on part A. It's kind of a normal thing. So x squared times derivative of y is dy dx plus y times derivative of x squared is 2x. So we get a little product rule there, plus 2y first dy dx equals 2. And then I think we want to get the dy dx by itself. So we got dy dx. I'm going to factor it out. You got an x squared plus 2y. I'm going to move this term to the other side, minus 2xy. I'm going to divide both sides by x squared plus 2y. I don't really think we can simplify that at all. So that's A. B says find the points on the graph where there's a horizontal tangent. Well, that'd be where the slope is 0, which is the thing that we just found. So we would say equals 0. So that's going to be when the top equals 0. So when 2 minus 2xy equals 0, so that's going to be 2 equals 2xy. That's going to be xy equals 1, which, okay. Well, how do we finish solving this? Let's see. We have the original equation. Well, when y equals 1 over x. So I guess what we could do is we could plug this back in to the original equation, and then, because that's another equation for y and x, and then we should be able to solve for y or x, you know. So I'm going to do that x squared, and where I see the y, I'm going to put 1 over x plus y squared. I'm going to put 1 over x squared equals 2x. So now I'm going to try and solve this equation. So that's going to be x plus 1 over x squared equals 2x. So I don't know, should we bring everything one side? 1 over x squared minus x equals 0. Give a least common denominator. 1 minus x cubed over x squared equals 0. So that's going to be what? 1 minus x cubed equals 0. So that's going to be x cubed equals 1. So that's going to be x equals 1. Okay, we're trying to look for a point, so we're going to plug that back in up here. So y equals 1 over 1 is 1. So the point's going to be 1 comma 1. This is the location on the curve xy pair where there's a horizontal tangent. How about vertical tangents? Well, that's going to be when your derivative is undefined because division by 0 is blowing up and going to infinity. Something over 0, right? Undefined. Okay, so we're going to set the denominator equal to 0. And I think now we have kind of a strategy. We use the same strategy as last time. So 2y equals negative x squared. Y equals negative x squared over 2. So I'm going to plug that back into the original equation. So we got x squared, negative x squared over 2, and for y, plus negative x squared over 2 gets squared equals 2x. So negative x to the 4th over 2 plus x to the 4th over 4 equals 2x. I kind of want to get rid of these fractions. Right? Isn't that nicer? So it's going to be 3, it's going to be 1x to the 4th. So they're going to move everything to one side, set it equals 0, and factor it. So we get x equals 0, and we get x equals 2. So we get 2x values. Is that possible? Sure, it could happen at multiple points. So I'm going to plug this back in up here. So y equals 0 square root of 2 is 0. So one of the points is 0, 0. And we'll plug that back in. We're going to get y equals negative 2 squared over 2. So it's going to be negative 2. And so that point's going to be 2 comma negative 2. Did I do that right? Yeah, I made a mistake right here. This should be negative, right? So this is going to be negative 2. The answer comes out the same for the y. But yeah, I made a little mistake there. That's it. Yeah. Yeah. Looks good to me. Right? The way I got this, I got x cubed plus 8 equals 0. X cubed equals negative 8. Cube root of both sides. X equals negative 2. So there you go. That was a good one.